Hey, it's Rob. Welcome to a Math 8 lesson on slopes and intercepts. I'm going to do two different worksheets. I'm just going to do one or two questions apiece. Let's go over interceptions. Interceptions are an awesome and fun part of a football game. What happens when there's an interception? One of the players on defense crosses the path of the pass so that they catch the ball, and even better if it's a pick six and they run it back for a touchdown. So right here is an example of an interception. If this is the path of the football and I cross the path, I meet that ball at the same time and place where it crosses. An intercept is where something crosses. So if I'm going to do a lesson on x-intercepts, it's going to cross the x-axis. If I do it on the y-intercept, it's going to cross the y-axis. So I'll just do a couple quick questions here. So let's look at number one. We're also going to go over slope. Slope is rise over run. Slope is rise over run, or the change in y over the change in x. Change in y can be rewritten as y1 minus y2, and the change in x can be rewritten as x. Which one did I say first? One? x1 minus x2. Now that doesn't mean I can't do y2 minus y1 and then do x2 minus x1. Either one works. You just got to stick with the pattern. A lot of times I think students just like to do the triangle for slope, so let's do that. I just need 2 points. They don't have to be consecutive. They can be further apart. So I'm going to choose this point and this point. I'm going to make a triangle out of it. It rises 2 up, which is positive. It runs right, which is positive 4. That can be reduced to 1 over 2. The slope is 1 over 2. Okay, need more detail? Message me. This is review, so I went a little quick on it. X-intercept, where does it cross the x-axis? Right here. That point is -2, 0. You just say the x-intercept is -2 because the y value for an x-intercept is always 0. Every single point on the x-axis has a 0 for the y. And vice versa. Every single point on the y-axis has an x value of 0. So where does this graph cross the y-axis? Crosses right here, which is 0, 1. You could just say 1, or you can write the point 0, 1. Okay, let's make sure you understand what it is we are talking about. So I'm going to pick a random problem. Let's put stuff in context in real life. So I'm going to look at number 12. Distance from home, distance in miles depending on the time in hours. What was the distance from home at time 0? You go to 0, you go up to the graph, it's right here, halfway between 150 and 200, so that would mean it's 175 miles. Why is this question on this paper? Because this point is also called the what? Crosses the y-axis, is the y-intercept. It is the meaning of the y-intercept. You are, or whoever is, 175 miles from home at the beginning of the story, time 0. What was the rate of speed? Okay, rate of change is often slope. Rate of change and slope, they mean the same thing. But they give you an extra hint, MPH, which stands for miles per hour. Per often means divide. So let's do that. What's the change? It goes from one point to the next, down. It goes down how much? Down is negative. Remember, that was 175. I don't need to recount it. And it goes to the right, 4. Is speed negative? You ever see negative speed? No, but that negative does mean that the person's getting closer to home. And that was for 4 hours. So if I was going to put that in the calculator, I honestly wouldn't give a negative speed. The negative is more about the direction. The traveling in could be also called a vector. So 175 divided by 4 comes out to like 43.75, and the units were miles per hour. Okay, this is slope and y-intercept in context. Okay, so we'll do that again with some slightly harder questions on another worksheet. Now this worksheet's harder. There's harder algebra on it. I didn't get deep into the algebra, so I'm gonna let you for now cut some corners on the algebra, but I'll still go over the proper algebra. So I'm gonna do question 3, and then I'll do one more problem. So it says state the x and y intercepts of each equation, and then use it to graph, meaning plot the points and connect the dots. So remember from the other lessons, if I'm crossing the x-axis, the y value is going to be always 0. So for an x-intercept, we're going to make y 0, and vice versa. For a y-intercept, we'll make x 0. So I'm going to rewrite this equation. 12x plus 9 times 0 equals 15. Okay? So let's simplify this. Is there anything I can write simpler? Sure. 9 times 0. 9 times 0 is nothing. I'm just going to cross it out if you don't mind. And then I'm going to write 12x equals 15. Now this is where you have to get into a little bit of algebra. What do you multiply by 12 to make 15? It's going to be some kind of decimal or fraction. And if I needed to find the x, if I don't know what to multiply by, I'm going to put this in and divide. And the reason for that is because the opposite of multiplication is division. And I'm going to divide by the coefficient or number in front of x, because it will undo each other and give me 1x. And then this would go in the calculator and would come out to be 1 2/3 or 1.6 repeating. I like fractions better. Math 7 is like fraction class. Alright, and then I'm going to do this again. There's not a lot of room, sorry about that. To get the y-intercept, where the graph crosses the y-axis, the x is 0. So 12 times 0, well, that's going to cancel. It's going to be completely gone. And I'm not going to show proper algebra for this one. If I don't know 9 times what is 15? Well, the opposite of times is divide. So to work backwards, I would put in the calculator 15 divided by 9. And that'll give me my answer. This is not proper algebra. I am still showing work though. That's going to be 1 1/4. These are not nice to graph. You know what? I'm probably just going to pick a few questions from this so we can avoid some of these bad numbers. Not that bad numbers don't exist in real life. I just don't want to have all these headaches. So let's see. We put in y is 0 and x is 1 2/3. X is 1 2/3 and y, so that's like here. It's not perfect. I'm not looking for perfection. So this is 1 2/3, 0. This one we put in x is 0 and we got 1 1/4 for y. X is 0, 1 1/4. I only need 2 points to make a line. On a normal day, I would ask you to use 3 points. But if the directions say to graph using the x and y intercepts, then I just follow the directions. Here's the x-intercept, here's the y-intercept. Draw a line. I got a graph for 12x plus 9y equal to 15. There's all sorts of numbers that can go in there that will work in that equation. All right, so I'm going to do number 4, and then make sure you pay attention to the directions to see which questions I actually want you to do. If you feel like doing extras, you can do extras. Number 4 says, the table shows the cost for clothing store to buy jeans and khakis. The total cost for Saturday's shipment is $1,800. It's represented by the equation 15x plus 20y equals 1,800. Use the x and y intercepts to graph the equation, then interpret the x and y intercept. Are you a jeans person or khakis? Honestly, I don't think I've seen one student in my class ever wear khakis, except when somebody dressed up for Halloween as Jake from State Farm. I think that's the only time I've seen anybody at this school wearing khakis. Pretty much, yep. And maybe if they're dressing up for a basketball game or something. But during COVID, who's playing basketball? In any event, I'm going to write store on here because you really shouldn't have a graph without a title. So remember, the x-intercept crosses the x-axis and y is 0. So if I type this equation, it's 15x plus 20y, but instead of y I'm going to use 0. I would get this. 20 times 0 is 0. So I get 15x is 1,800. Now you can show me proper algebra or not. But if I don't know what to multiply by 15 that's going to give me 1,800, I'm going to put 1,800 in my calculator and reverse the operation to get division and divide by 15. Like when you do cross multiplying in proportions after you get a step like this, we do whatever we do on one side, we do on the other because it needs to stay equal. 15 divided by 15 gives me 1x. I don't have to write the 1 if I don't want to. 1,800 divided by 15 is 120. I have no idea what that means right now, so I better go back and look at the x. X is how many jeans? That's 120 jeans and no khakis. Like a normal day at work. Unless you're working at Target, it's all khakis and no jeans. Okay, so I got an x-intercept. Crosses the x-axis at 120. Luckily this number is a little easier to plot because it's not a decimal or a fraction. And then I need to go do the y-intercept. Maybe I should have just labeled this up here. Give myself room to do a y-intercept. I didn't really think it through. Sorry. You guys can erase, right? It's cool. It's fine. So I'm going to do my y-intercept. X is 0, so my equation is 15x, but that's going to be replaced with 0. I always use parentheses when I substitute. Oops, I wrote 12. I'm going too fast, Mrs. Roberts. Slow down. 20y equals $1,800. 15 times 0 is 0, so it's gone. I just cross it off. 20y is here, it's still equal to 1,800. 20 times what is 1,800? This one I can guess pretty easy, but I like it to show work. So in the calculatora, I'm going to take the 1,800, I'm going to divide it. We divide with fraction bar in 7th grade because we work down. Even though I did this sloppiness, it's still pretty darn neat. So I'm going to divide by 20, and I'm equally going to divide by 20 on the other side as well, because it's equal. You must do equal things to keep something equal. The zeros will divide off because 10 goes in, and 18 divided by 2 is 9, and there's 0 there. That's a little elementary school stuff. 20 divided by 20, anything divided by itself is 1, and I'm left with y, which means it's 90 khakis and no jeans for that amount of money. For $1,800, if you are at all interested, you can buy 90 khakis from this store, but you can't get any jeans. And for $1,800, you can buy 120 jeans and no khakis. And then, for $1,800, you can buy a mixture of jeans and khakis. And the graph looks like this. Now, a lot of graphs, I continue the line. If I continue the line over here, that would be quadrant 2, where x's are negative. There's no such thing as negative genes. Ooh, that would be an interesting concept. Negative genes, what would they do? Put them on and erase your legs? I don't know. But there's no such thing as negative khakis either. All right, so I'm just going to do a select questions from here. Just pay attention to the assignment. All right, have a nice day. I'm going to go get another cup of coffee because I'm pretty sure I need it.